Okay. To do part A, what we need to do is set up an equation using the law of sines. So we'll do sine of 83 degrees over 15 equals sine of 44 degrees over AC. And then we just cross multiply, giving us AC times sine of 83 degrees equal to 15 times sine of 44 degrees. And then you just divide both sides by the sine of 83 degrees in order to get AC by itself. And you put the whole thing in your calculator. And when you round to 3 significant figures, you will get 10.5 centimeters. This problem, we are trying to find the area of triangle ABC. The first thing I recommend doing is finding the measure of the missing angle in that triangle. So we're just going to do 180 minus 44 degrees minus 83 degrees, and we will get 53 degrees. And now we are able to use the formula area equals 1/2 AB times sine of angle C, which in this case our labels are all a little bit different, but that's okay. We just know that we're going to do 1/2 times the two sides that we have, so 15 and 10.5 times the sine of the included angle, which is 53 degrees. And when we put that in our calculator, we get that the area is approximately 62.9 centimeters squared. And that would be the area of triangle ABC. See, we have to find half of the area of the triangle that we found in part B. So we are going to go ahead and take 62.9 and divide it by 2, and that will give us 31.45. And then we can take that value and plug it in right here in the formula for the area of a triangle. So we will have 31.45 equals 1/2, and then we're going to plug in the side lengths on the green triangle. So we're going to plug in a 6 and a 10.5. And then we just have to use theta for the angle because we don't know what the measure of the angle is. That's the whole point of this problem, is to find that. So then what we can do is go ahead and clean this equation up a little bit. And when we do, we will get 31.45 equals 31.5 times sine of theta. And that 31.5 comes from doing 1/2 times 6 times 10.5 in the calculator. And now, to start to get theta all alone, we're going to just divide both sides by 31.5. And I am not going to put this in my calculator yet. So that will give me 31.45 over 31.5 equal to sine of theta. And then, of course, to get theta by itself, we're going to do the inverse sine on both sides. So that would give us the inverse sine of 31.45 over 31.5 equals theta. And then you just put that in your calculator, and it should tell you 86.7713, and it might just keep going from there. But we are just going to go 3 significant figures. So theta is approximately 86.7 degrees. Now, the problem gives us a big hint that this is an ambiguous triangle when it says to find the possible values of theta. So you have to remember that to find the other possible value of theta, all you do is take 180 degrees and subtract the 86.7 degrees from there. And when you do, you're going to get 93.3 degrees. Oops. So theta is 86.7 degrees, or it can also be 93.3 degrees. Since we are given that angle theta is obtuse, that means we are going to use the 93.3 degree angle that we found in part C. And then we're also going to go ahead and use the cosine rule. So for this exact problem, that would mean that we are plugging in 6 squared plus 10.5 squared minus 2 times 6 times 10.5 times cosine of 93.3 degrees. And we have to remember that this is actually going to give us our segment squared. And so I'm going to go ahead and right off the bat, I'm going to put everything in the square root. So square root both sides. And then I am ready to go ahead and put this in my calculator, and it will give me the length of segment CD. And when I put this in my calculator, going 3 significant figures, oops, I get that the length of segment CD is approximately 12.4 centimeters. And I am finished.